Hello everyone, welcome to another video. So in this video, I just wanted to take a little bit of a deeper dive into understanding these multi-step, these two-step equations that we've been encountering so far. So a lot of the time, when we're dealing with these types of equations, the thing we're trying to get to is, in essence, a value of x that makes the equation true. So that makes the left-hand side equal to the right-hand side. Now, when we look at this x, we kind of want to see, when we solve this equation, we want to see how it was built up. We want to look from the perspective of x and sort of see what was kind of done to it last. Because in doing this, we can apply our opposite operation like we talked about in the previous videos and sort of get us closer to a value for this x. Now, in essence, solving equations is really all about peeling back the layers to get to our unknown, to get to our x. So just to have a closer look at this, getting our x from x to 2x minus 3, we just want to see what we actually did to get from the left to the right here. Now, to get from x to, say, 2x, what do we do here? Well, to get from here to here, let me let's color coordinate this a little bit better. So 2x, and then ultimately to my last thing. Well, we want to see what do we actually do to x to get it to 2x. So we multiplied it by 2. Because writing 2x in algebra, this is just short form for 2 times x. Now, to get to the next thing, to kind of complete this left-hand side, well, we took all of this and we subtracted 3 to it. So to build x up to get to 2x minus 3, first we timesed it by 2. That was the closest thing to this x. That was the first change we sort of made to it. And then we subtracted 3 from whatever 2x was. Now, in peeling this back, let me do another line here. So to get from, say, 2x minus 3 to 2x back to x, we want to we see that what we end up doing kind of ends up being the opposite, because 2x, we've subtracted 3 from it. So what can I do to undo this subtracting of 3 to get me back to 2x? Well, I'm going to do the opposite. So if I've minus 3, I will be plussing 3 to get me back to 2x. Think of just a number line, right? If you start at negative 3 and you add 3 to that, you get to 0. So 2x plus 0 is the same as 2x. So we're doing the kind of, we're doing the opposite thing at each step to get us back to x here. Now, here 2 has been multiplied by x. So what can I do to undo multiplying something? Well, I can divide by that thing that's multiplying. So you can see when we look at the bigger picture here, to build up this left-hand side here, we did the following process in this first line of working. So therefore, to undo this, to slowly peel back the layers to get us to x, we're going to be taking the operations and doing the opposite. So you can see here, subtracting 3 was the last thing we did. So the opposite of that, adding 3, will be the first thing we do. when we go the other way. Now, the thing we did in the middle was timesing by 2. So we're going to divide by 2 to get back to my x. Now, let's actually just take a moment to actually solve this equation. Now, this will be the only example I do in this video because I want to show you this kind of peeling back idea, right? So I have 2x minus 3 equals 5. Now, what's the very last thing we did here? Well, we subtracted 3 from 2x. So that is going to be the very first thing I do when going the other way. So if I've minused 3 from this thing and I get 5, so minusing 3 from some number, and that resulting in me getting 5, that tells us that my number here is going to be 3 more than 5. Hope that logic makes sense. Let me repeat that again really slowly. If I have minused 3 from a number, and that gave me 5, then my number is going to be 3 more than 5. This is the idea of opposites, and we're almost working backwards and peeling these layers. I want to find what 2x was before we subtracted 3 from it. And in doing this, that's where our opposite operation comes in. So adding this 3 here is going to cancel out this particular thing here. So that gives me 2x. In essence, it gives me 2x plus 0, which is just 2x. And adding 3 to 5 gives me 8. So I have found what 2x was before we subtracted 3. So this is my next layer. I've kind of peeled this first layer back, and I have another statement which is the same as the first one, but just simplified here. Because I found out I was given that 2x minus 3 was 5. So then 2x must be 8. It must be 3 more than 5. Because minusing 3 from 8 gives me 5. So I'm always doing this opposite procedure here. Now, at this point, a lot of you can probably see that this just becomes a one-step equation. So if you know your arithmetic, you know what multiplies by 2 to give me 8. But let's just go through it slowly again. We want to do the opposite now again. We want to see, well, what number was multiplied by 2 to give me 8? And the opposite of multiplying by 2 is dividing by 2. And now with equations, what we do to one side, we do to the other side. So here, because that's what the equal sign tells us. Because of this equal sign, the left and right are equal. So what we do to one side, we have to do to the other side. Now, some number was multiplied by 2 to give me 8. So I can find that mystery number by doing the opposite of timesing by 2, and that is dividing by 2. Because 2 divided by 2 just gives me 1, which gives me one lot of x, or just x. Because I can make x out of dividing 8 by 2. And this gives me 4 as my answer. Now, that very last point I made, let's just look at that again really quickly. So 2 times 4, for example, gives me 8. I can also make that 4 by dividing 8 by 2. So you usually, at least when you do this inspection state where if you know your times tables, you can get here pretty easily. What you maybe don't realize you're doing in your head is that you are just expressing this number, x, as the opposite to timesing by 2. So you are dividing both sides by 2 here. And this ends up giving us x equals 4 as an answer. So let's just quickly recap what we've done. We looked at how we built this x, this left-hand side that I've put a purple rectangle around. I'm just showing you here how we built up from x. So starting at x, how we got to 2x minus 3. So I first times 2 to it to give me 2x. I then subtracted 3 from that to give me 2x minus 3. So to go back the other way, I take the last thing I've done, which is minusing by 3, and do the opposite. And you can see here, for example, these are opposite operations. Adding something is the opposite to subtracting, and dividing is opposite to multiplying. And then this is how we can eventually model our answer. This is how we can show working out. We have our first layer, 2x minus 3 equals 5. What was 2x before we subtracted 3? Well, that's something 3 more than 5. And then we proceeded along to find what x was. So we're chipping away at these layers. I'm going from here to here, down to here. And this is how we can solve equations systematically. Thanks so much for watching, guys. I'll see you in the next one.